Hi and welcome to this video where I'm going to start explaining how you convert between solubility and solubility product. In this video we're only going to focus on one type of salt, which is what we call an AB salt, so a 1-to-1 ratio salt. In a subsequent video I will look at 1-to-2 ratio salts. Okay, before I talk about that though, I think it's really important that we talk about what units we use when we talk about solubility. Now typically, up until this point, you will have been used to using mole per litre as the only unit for concentration. But in fact there are multiple units that you can use for concentration, and one that commonly comes up in this standard is grams per litre. So you should be able to convert between moles per litre and grams per litre. You can do that using your moles equals mass over molar mass formula. Now you could remember this, or you could just think about it logically. Okay, I'll give you an example in a moment, but first it's important to remember that no matter what unit you get given in a question, Ks is always calculated using mole per litre solubility, and Ks is always unitless, as any equilibrium constant is. So just to convert from moles per litre to grams per litre, or vice versa, the first thing to think about, let's imagine we've got lead chromate. We've been told its solubility is 5 times 10 to the minus 7 moles per litre. What that means is that 5 times 10 to the minus 7 moles, or 0.0000005 moles of lead chromate will dissolve in 1 litre of water. Those units, remember, they tell you something useful. So if I've got 1 litre of water, then 5 times 10 to the minus 7 moles multiplied by the molar mass is the equivalent of 1.62 times 10 to the minus 4 grams. So we can say that the solubility in grams per litre is 1.62 times 10 to the minus 4 grams in 1 litre, which is the same thing as 5 times 10 to the minus 7 moles per litre. All we're doing is converting from one unit to the other and back again. So it's just useful to be able to recognise those different numbers. They do come up from time to time. Okay, so if we look at calculating solubility from the solubility product, Ks. So let's first off imagine that we have a salt. We're going to call that salt AB. So it's some amount of A plus and some amount of B minus. When we dissolve it in water, we can talk about this expression, where AB is in equilibrium with A plus and B minus. Now, we can also write the Ks expression, and I always recommend starting with the equilibrium equation and then the equilibrium constant expression. So Ks is equal to the concentration of A plus times the concentration of B minus. Now, because we don't know what the solubility is, that's what we want to find out, we're going to pretend that S amount, we're going to call it S, you could call it X if you prefer using X's from maths, it doesn't matter what you call it, but S amount of salt AB is going to dissolve in water. And so if S amount of AB dissolves, we're going to get S amount of A and S amount of B. We can then substitute those directly into our equation. So if we know that the concentration of A plus is S, because that's how much of AB dissolved, and the concentration of B minus is S, then we can put those numbers straight in and say that actually K is equal to S squared, or S is equal to the square root of Ks. Now, because Ks is a constant, we'll usually be provided with that piece of information, and so we can go ahead and use it. So let's look at an example for a second. If we've got barium sulfate, the textbook tells us that the solubility product for barium sulfate is 1.25 times 10 to the minus 10. Now, we know that barium sulfate dissolves to form barium ions and sulfate ions. And because of the formula, this is a 1-to-1 ratio. So, Ks is equal to the concentration of barium times the concentration of sulfate. Now, if we have S amount of barium sulfate dissolving, because we're at the solubility limit, then we can say that the concentration of barium is equal to the concentration of sulfate. We can see that from the equation, and they're both going to be equal to S. So then we can substitute that directly into the equation and say that actually we know Ks is equal to S squared, therefore S must be equal to the square root of 1.25 times 10 to the minus 10, which is equal to 1.12 times 10 to the minus 5 mole per litre. Now this shortcut is great, the Ks equals S squared one, and they even give that to you on your formula sheet. But actually working it out from first principles every time to me makes more sense, because you can only use this shortcut if you have a pure solution of barium sulfate. As soon as you throw anything else into the mix, then this shortcut won't work. So always go back to first principles, but that's a useful way to think of it. We can also go the other way. So if we know the solubility, we can work out Ks. So let's imagine we've got calcium carbonate, and we know that the calcium carbonate has a solubility of 1.3 times 10 to the minus 4 mole per litre. From this we can calculate Ks for calcium carbonate. We know that calcium carbonate dissolves to form calcium ions and carbonate ions. And if we have 1.3 times 10 to the minus 4 moles per litre of calcium carbonate dissolving, then that's going to give us 1.3 times 10 to the minus 4 moles of calcium ions and 1.3 times 10 to the minus 4 moles of carbonate ions. We know that Ks equals the concentration of calcium times the concentration of carbonate, so we can put those numbers straight in. 1.3 times 10 to the minus 4 times by itself is the same thing as 1.3 times 10 to the minus 4 squared, and therefore Ks for calcium carbonate must be equal to 1.69 times 10 to the minus 8, and it is a Ks, so it is unitless. Okay, I do recommend you have a look at a few more of these. There are a lot of opportunities. Work through your SciPad or Education Perfect and practice some calculations. When you've done that, I'll see you back in the next video where we're going to look at doing these types of calculations for more complicated salts.